In the heart of a city that never calms down, where the ground is as soft as a sponge and the concrete seems like it has no real right to stand, a journey begins that defies the laws of physics. In this place, the winds up high aren't just a breeze, but a force strong enough to break airplanes. The site is surrounded by buildings, roads, and people. No room for storage, no room for error. And yet, the goal isn't just a building, but a vertical city whose mass will reach 500,000 tons, forcing itself to stand up to an earthquake that could reach 9 on the scale. Here, before any floor could rise, the project had to go deep down. The biggest machines on Earth are called in, and the miracle starts right under everyone's feet. Digging isn't a choice, it's a necessity. Deep excavation all the way to solid rock, because anything less means this giant will move, and everything above it will move with it. The machines pound the ground with massive force and start driving piles. Not regular piles, but roots as deep as a small skyscraper underground. Reinforcement cages, made of steel 5 times stronger than normal steel, are lowered in, and chemical fluids are used to stop the sides of the excavation from collapsing. Then the concrete rushes in and pushes the fluid out, hardens, and turns into a man-made pile that's like a piece of rock born from cement and steel. Hundreds of piles build up, a hidden forest no one ever sees, but it's what will carry the sky in a little while. The pile heads are broken off with precision, so they can be tied together. Then a unified steel mesh is woven over them. Protecting the foundations from groundwater becomes a matter of life or death. Because the water here isn't just moisture, it's an enemy that weakens any metal if it's left undefended. Then comes the moment where stopping just isn't allowed. The big pour. The biggest steel mat is woven by hand. Then thousands of cubic meters flow in to form the raft foundation. The chemical reaction generates enough heat to boil water, so ice is used to cool the mix and prevent cracking. Any tiny crack now isn't just a flaw, it's a disaster waiting to happen. After days of waiting, a base is born as solid as natural rock, as if the earth itself has signed a contract to carry the load. Only at this point is the heart of the project planted, the giant crane. It's not just a crane, but a beast that will live with the tower and climb with it. The smart formwork is set up so it can keep jumping upward, and the concrete is tested to handle insane amounts of pressure, because the only way, now, is up. The beast finally comes out from underground. The central core formwork never stops, climbing 24 hours a day, while hydraulic jacks push an entire factory toward the sky. The race against time begins. The concrete has to be poured with extreme accuracy at precisely calculated times, or the bonding will fail and cracks will open up in the main backbone of the building. Around the concrete core, the steel skeleton starts to wrap it in. Steel pieces as heavy as a tank are lifted and fixed with millimeter-level precision. Men facing the wind connect the joints and secure every connection. There's no time to be afraid of heights here, because every step in this place has one meaning. Either you keep going, or the whole story collapses. Metal decks are laid out like bridges, and the concrete pumping arteries start working. To reach these heights, you need pressure strong enough to throw a car into the air. Pressure that lifts the concrete as if it's a liquid defying gravity. Floors stack up one after another, and with every rise, the walls get thinner to cut down the weight, because every extra kilogram up here turns into a deadly burden above. Then, something happens that looks impossible to anyone watching. The crane lifts itself. It climbs the structure, so it's always above everything, almost as if it's feeding off the tower it's building. We've passed the halfway point, and the winds are getting fiercer. So huge steel outriggers are installed to link the core to the outer columns, stopping the tower from bending to the storms, like steel ribs tightening the body from the inside. To keep it perfectly straight, the engineer's eye isn't enough. Satellites are used to monitor the vertical alignment of the tower with extreme precision. Even the sun, that quiet force, can make the building lean a few centimeters because of thermal expansion. So adjustments are made constantly, because a small deviation at the bottom means a terrifying deviation at the top. Inside this giant, entire floors are dedicated to being its heart and lungs. And water here doesn't just go up with one button press, but through staged pumping stations, a city above a city inside pipes and non-stop pressure. The closer we get to the top, the language changes. We use lighter concrete and install balconies hanging in the air that literally challenge gravity. Every weld is inspected like a surgical operation, because any weakness here is unforgivable. And to speed things up, pre-made rooms are lifted and installed like Lego pieces. Off-site engineering that cuts months of risk. Now we're in the stratosphere of architecture. The air is thin and the cold bites into the concrete. We have to heat it so it hardens the way it should. With the structure almost complete, the secret of its stability comes in: the giant pendulum. A massive ball is hung inside, moving in the opposite direction of the tower's sway to bring it back into balance. A system that absorbs the energy of storms, the way a chest takes a heavy blow without breaking. The structure is ready, but still naked. Time to dress it in its glass suit. Huge glass panels are lifted using vacuum technology and fixed from the inside to reduce risk. They're tested with jet engines and water cannons, because the glass here isn't just for looks. It's a shield against heat and UV rays, a wall against noise, and a weapon against the city's storms. The glass skin climbs at an amazing speed, and the tower starts to disappear and blend in with the sky. Inside, capsules are installed that shoot up at high speeds, with air pressure systems that keep your ears from popping with the fast climb. Thousands of kilometers of wiring are laid to power this city, with robots and smart systems guarding it from fire, and AC units the size of houses lifted to the top to make the air breathable in a world above the ground. The outer cladding is almost done, and the shape of the top doesn't block the wind. It scatters it, because facing the air head-on means war, while scattering it means control. Then comes the final piece, the crown, the most dangerous stage, where the air is thinner and the winds are brutal. The crown is fixed with bolts the size of a human arm, and the scene closes on one simple fact. We've reached the top. One last question remains. How do we bring the crane down? The answer has the same spirit as the project. The crane takes itself apart. A smaller crane brings the big one down. Then, that smaller one itself is taken down by elevator. The building's wounds are closed, gaps are filled, and the highest window cleaning operation in the world begins, with daredevils facing the void to bring the shine back to the glass. Inside, the concrete turns into luxury, and the finishing touches breathe life into the place. The lighting that will guide millions is tested, and nature is brought indoors to soften the harshness of height, while an electronic brain monitors every breath of air and every drop of water, because this isn't a building. It's a living thing. The barriers are removed, and the street returns to the city. With the first light of morning, the achievement shines. Years of work are summed up in a single moment, and the place becomes an icon and a challenge for the future. This is how humans make miracles. The journey is over.